Sadly, very few people know what the internet is, let alone how it functions. So today we're going to focus on looking at the inner workings of what makes the internet tick. I've got a great video here that introduces you to the internet and some of what happens behind the scenes. Make sure you go back to the presentation, watch this video, and be sure that you can answer the 3 guided questions before you move on. I want you to think of the internet as a system of digital roads, as an information superhighway that carries information between computers and computer networks. I want you to think of the data as cars on that road. So the internet is like our interstate highway system, but instead of transferring people from place to place, we're transferring information. The internet is actually a physical system, and there are a lot of physical components, a lot of physical architecture that needs to be in place to transfer information. Information can be transferred around the world in a number of different ways. Fiber optic cables can use the power of light to transfer information through the ground and on the seafloor from place to place. Or information can be transferred through the air using wireless towers or satellites. So there are many different ways to physically send information around the world using the internet. Students always seem to be surprised by the fact that so much of the internet relies upon cables being laid on the seafloor. This is ultimately what connects continents together, what allows someone in the United Kingdom, let's say, to access a web server in Virginia. So I've got a great resource for you I want you to take a look at. On this website, you'll actually see a map of all the submarine cables that have been laid all around the world to make the internet possible. At any given time, there are ships out there laying cables, repairing cables, and it's fascinating to explore this map. So make sure you go back to the presentation and you do that before moving on. How the internet works. The big thing to understand is that in order for the internet to work, computers need to have an address. So just like your house has a unique street address that allows me to send you a piece of mail, well, computers need the same thing. And we call this an IP address, or an Internet Protocol address. So any computer that is connected on the internet needs to have a unique address called an IP address. And this is ultimately what allows other computers to transfer information to it. When the internet was originally designed, there was a format called IPv4. This was the original version of IP addresses, and it's the one that you're probably familiar with. In this example, I use 208.93.105.218. This was an old style, what we call IPv4 or version 4 IP address, and it was 32 bits in length. The people who originally designed the internet had no idea how popular it was going to become. And so soon we started running out of addresses. So they came up with another version called IPv6. That is the longer version you see on the screen, and it is 128 bits in length. So that accommodates many more devices connected to the internet. There's also something called the domain name system, or DNS. When you are on the internet, you're used to typing in human-friendly names like www.google.com. But what you don't realize is that computers cannot communicate and talk to one another using those human-friendly names. They need to know the IP address, the unique address associated with the computer that has that information. So there's a system called the domain name system, and what it does is it translates these human-friendly names like www.google.com to the more computer-friendly IP addresses. So it's a very simple process. You're browsing the internet and you put in a URL that you want to go to. Your URL is something like www.colstock.com. And then your computer will do what's called a DNS lookup. It will ask a set of servers for the IP address related to www.colstock.com, and it will pass it back to your computer. Once your computer has that unique IP address, the address of the computer it needs to communicate with, it will actually send a request to that computer, and then that computer will respond back. That is what DNS does. So the real job of DNS is to act sort of like a telephone book, where you can look up the name of a resource on the internet and it will provide you back an IP address. The IP address is the location of the computer or computers that you can contact to get the resource that you want. You may have noticed that when you type into your browser, into the address bar, that the names you type follow a very predictable scheme. In reality, DNS has a naming hierarchy where all domains rest underneath what's called a root level domain. And then domains are broken out even further into what are called top level domains. You've seen many different top level domains in your life, like .com, .org, .biz, .us. So domains are organized under top level domains. The thing that you and I refer to as a domain is really called a second level domain. And those are things like Google, or Apple, or Coalstock. And then last but not least, domains can be split out even further into what are called subdomains. So if you've ever searched for an image on Google, for example, you go to images.google.com. Images is a subdomain. Google is the domain or second level domain. .com is the top level domain. And of course, all domains belong to the root level domain. Now it seems a little bit complicated, but this is exactly how the system is put together, and it's important that you know that it exists, that there is a method to the madness. Another thing to understand about the way that the internet works is that not every computer is connected directly to the internet. In fact, most of us get our internet access through what's called an internet service provider, like Comcast or CenturyLink. So these ISPs have the equipment, they have the infrastructure, the know-how to directly connect to the internet. And what they do is they sell us access, the ability to tap into this humongous communication network known as the internet. Unfortunately, the ISP market, the telecommunication market, is very much an oligarchy. There are only a couple companies throughout the United States that provide ISP services. And depending upon where you live, you may have very little choice. This map shows you the top internet service providers by state. As a network, the internet is considered a distributed network. Distributed networks are fascinating things that are very similar to how ant colonies functions or how the neurons in your brain function. In a distributed network, responsibilities and control are shared far and wide. So every node or thing in the system has a role to play in its functioning. So when it comes to the internet, all the computers and all the devices connected to the internet can have a role in how information is transferred back and forth. The internet is what's called a packet switched network. When you request or respond to requests for information on the internet, your request to response is actually broken down into hundreds, thousands, tens of thousands of smaller pieces called packets. Each one of these packets can take its own path to the destination computer. And then when all of the packets arrive, they are reassembled in the order. So this animation right here kind of shows you what it's like. One host is requesting information and it got broken down into 3 packets. Those 3 packets took a completely different path, independent paths to the destination. When they got there, they were reassembled all over again. This is important because the internet needs to be fault tolerant, and packets need to be able to choose a quick path to the destination. So this whole idea is called a packet switched network. What ultimately drives the internet are protocols. Protocol is just a fancy word for rules. Vince Cerf and Bob Kahn came up with what's called TCP/IP, which is a set of protocols or rules that computers all follow to communicate with one another. We're going to shift gears a little bit. We're going to talk about the World Wide Web. Many people use the terms Internet and World Wide Web synonymously, but you shouldn't do this because they are separate yet related concepts. The World Wide Web is a system that allows people like you and me to create and share information. It was invented by Sir Tim Berners-Lee. This picture right here is the picture of the first web server ever created in the world. Sir Tim Berners-Lee created the technology and built the first web server ever using a regular home PC. What is the World Wide Web? The World Wide Web are the set of protocols and technologies that Berners-Lee invented to make web surfing possible. These are things like how URLs are constructed. You're probably familiar with the HTTP : at the beginning of your URLs. Well, he invented HTTP, the protocol where your browser and web servers can request and respond back and forth. So if the internet is the highway, the www or the World Wide Web are sort of like cars on the road. So addresses on the World Wide Web, those things that you're used to typing into your address bar, he invented this system. So you'll see on this slide, here's an example of a URL, or Uniform Resource Locator. Someone needed to come up with this scheme that combined the protocol, HTTP, with the subdomain, domain, top-level domain, and then whatever resource you are requesting. So he's the person who constructed this thing, the structure of it that you put into your address bar. So he created the URL system. He also created HTTP, which is Hypertext Transfer Protocol, which is the language of the web server. This allows your browser and a web server, which hosts the content, to talk back and forth. All the rules that govern how they communicate, HTTP is another thing he invented. This is part of the World Wide Web. So your browser sends requests and the web server sends responses. It knows what communication language to use because your URL starts with HTTP or HTTPS. The P stands for protocol. So rules are extremely important. Part of your address that you type into the address bar actually has what rule or what protocol to use at the very beginning. So web servers are extremely important. I showed you the picture of the first web server ever that he built. Web servers are specialized computers that serve content. So they host information, and then your browser can request from that web server whatever information that it wants. For example, if you want to watch Keyboard Cat, you are going to make a request of a web server. That web server will respond, and next thing you know, your browser will be showing you the best video ever. So web servers serve content, and we request of them the information we want. Also part of the World Wide Web are the three main client-side technologies you will be studying in this course: HTML, CSS, and JavaScript. These are languages that in concert allow your browser to show you interactive web pages that make web surfing possible. So this is the focus of this class, and web pages are ultimately made of HTML, CSS, and JavaScript. Let's break down each one of these technologies one by one. After all, this is the focal point of the class. HTML was invented by Berners-Lee and is short for Hypertext Markup Language. HTML is the language used to create web pages. Web pages are built or made up of HTML elements. Elements are placed into a web page using what are called tags. CSS, which is short for Cascading Style Sheet, is the language used to style web pages written in HTML. So CSS focuses on the presentation rather than the content and structure. In CSS, you create what are called CSS rules or rule sets to style the HTML elements on the page. And last but not least, JavaScript is the language of the browser. It is an interpreted programming language that allows you to add interactivity, real power to otherwise lifeless web pages. This is what allows your web page to do meaningful things. The big takeaway is that there's a big difference between the internet and the World Wide Web. Do not use the terms internet and World Wide Web interchangeably. The internet is sort of like the superhighway that information can travel on, and the World Wide Web are kind of like the cars that travel on top of the internet. So the internet is a global computer network in which computers are connected using a common protocol, TCP/IP, whereas the World Wide Web uses the internet along with the technologies created by Berners-Lee so that we can share and link information. Remember, the World Wide Web uses the internet. The internet is sort of like the plumbing. It is the highway, but the www are like the cars. There are other things that use the internet other than the World Wide Web. There are so many services that we take advantage of day to day that use this highway system known as the internet. So that's things like email, peer-to-peer file sharing, FTP, voice over IP, so many different things, even instant messaging. And these things are not considered part of the World Wide Web. They're just one more thing that can use the internet. Remember, the internet's the plumbing that allows things to be connected so that information can be shared. It's the services that we put on top of it that make it powerful, like the World Wide Web, email, etc.